Good morning, everybody. I started in computer science 30 years ago, and I thought I was lucky. That was the time when nobody had heard of Microsoft, and I got in just when the computer revolution got going. But now I must tell you, today I think that the next generation coming into computing, they are the truly lucky ones, because now computer science is all about making society better. We need the next generation of men and women to build the software for the internet, for the banks, for the hospitals, for the cars and airplanes, for the cell phones, and for our games. And in UCLA Computer Science, we will do everything we can to give you a state-of-the-art education that will make you ready for going and taking a job in industry, for going to graduate school, or for starting a company. I was just talking to my colleagues 2 weeks ago about how many companies they have started together with their students just over the last 10 years, and it's many. And just last Tuesday, we had a meeting of 30 computer science students who had all expressed interest in starting a company or joining a startup company. We had CEOs of a handful of startup companies in information technology from Los Angeles. We had a couple of venture capitalists. And to boot, we also had the fellow who used to run nytimes.com. And we were talking about starting companies. There's a lot of opportunity here. Do come learn from us. Do come learn with us. Let's do projects together. And look at the people in our department. People from my department sent the first packet on the internet. One of my colleagues has an Academy Award for his contributions to graphics and vision. And we always have a lot going on. And I look forward to talk to you at lunch. See you soon.
Well, next, I have a special place. This is my department coming up next. I'm an electrical engineer, and it gives me great pleasure to bring on the stage our chair, Frank Chang.
Welcome to UCLA, the birthplace of the internet, and also many the wireless mobile giants around here. You know, they started, especially like a company like a Broadcom, and we have alumni that also started other companies like a Qualcomm, like a AMD, like a Maxim, that many of you in the Northern California is also quite familiar with. But I'm trying to say the following. As the name suggested, the electrical engineering department, actually, we have the job to tame the white horse, the electrons, you know, since the last century. We're the one who bring the millions of the dollars of the computers in 30, 40 years, and now down to a few $100 on your desk. That we call the Moore's Law. We are the discipline that has carried such a great job, revolutionary job until this day. That you make many things possible. So as you may see from the charts I'm trying to post here, there is a robots here, as you can see. Although you can see from the outside, you may think the muscles and the structures that belong to our friend departments, but actually the nerve, the brain, the intelligence that you could write down and to command these robots is actually from the the department. Yeah, so therefore, the departments now contains the three majors. One is that we call the physical and the wave electronics, as you may imagine, the electrons, when it starts to accelerate it becomes electromagnetic waves. And also the powers that transmit and received into your home and your stations. Yeah, and the next thing is the circuit and embedded system. That is the brain behind everything that you see in terms of the intelligence and the communications that you be able to enable. And the signal and the systems, including the algorithms that they have made all these electronics things possible. So with that, you will see never before we're facing the greater challenge even in this century. As I indicated to you, the so-called technology today, we're right at we call the 28 nanometer. That means the feature size of today's transistor, you may find the billions on your cell phones and your computers in terms of your microprocessors and other, we call the system on chips. You know, it continues to scale down, and we're aiming in 10 years from 28 nanometer down to per device, down to about 7 nanometer. 7 nanometer. As you can see, how much challenges that we are facing today, and you're the one which will continue to carry on the torch to march on. So therefore, with the 3 arms, the robots, you will see the actual right at the interface, they not only integrates, but also enables, I will make an emphasis on that, everything together. There are 3 cyberspace, physical space, and the biomedical space. For those the young men and women you're interested in this, we'll see you soon in the Dart Hall in about 1 hour. Thank you.
Our next department is Material Science and Engineering, and here's Professor Jinming Yang, chair of that department.
Thank you, Rick. And I'd like to extend my warmest welcome to all of you to UCLA. Most of you in high school may not be familiar with the field of material science and engineering as compared to other engineering disciplines. So you may ask, why do we study materials, and what is material science and engineering? So to answer the questions, let me start by saying that materials is the core enabling technology for all engineering disciplines and is critical to the development of new products. Let me give you a very recent example. The recent incidents in Southwest Airlines once again put the materials in the spotlight. Aluminum alloys were used in the fuselage, and they are prone to fatigue and corrosion. So airlines rely on periodic and very rigid inspection to find the cracks and to repair it accordingly. Would it be wonderful if we have a new material which is lighter and which is stronger with much better fatigue and corrosion resistance? Yes, we do have that material available recently. The airplane manufacturers, including Boeing and Airbus, are using a new material, we call it a carbon fiber reinforced composite materials, for the fuselage as well as the wing, for example, in Boeing 787, as well as the Airbus A350. Composite material has a much better corrosion and fatigue resistance. As a result, we can increase the cabin pressure, we can increase the cabin humidity, which will make us feel a lot more comfortable during air travel. Another example is you can find metal, polymer, ceramic, semiconductor, and composite materials in your iPod, iPhone, iPad. So at the heart of the material science and engineering discipline is the understanding of materials from the macro scale down to nanoscale. Indeed, much of the interest in nanoscience and nanotechnology stems from our ability to manipulate the structure of solids at the nanoscale. And our program offers our undergraduate students the opportunity to learn about many fascinating aspects of materials, including synthesis, processing, property, and performance of advanced materials. Our department is growing, and our undergraduate population and our research expenditure are at the all-time high. And we believe the linkage of the material science and engineering with important challenge in our society today, such as energy, environment, communication, healthcare, and infrastructure, is the most important reason for the growth of our undergraduate populations. And it will continue to be so in the years ahead. And our professors are also very actively involve our undergraduate students in cutting-edge research projects, which can be arranged as an employment opportunity or as an academic credit. So we believe that the UCLA's material science and engineering can provide you with an outstanding and exciting educational opportunity and research experience. And once again, I welcome you to UCLA, and I look forward to seeing you later.
Yeah, look at that. If you go back to that material science slide for just a second, the third bullet from the bottom, a small department with a low student-faculty ratio. I remember a few years ago I was on a committee that was reviewing the department, every 8 years, every department gets reviewed to make sure they're doing a good job. And they really got very high marks for the great student-faculty interactions that they have because of that small ratio. Okay, so we've made it to our last but not least department, the Mechanical and Aerospace Engineering Department, and here is that chair, Adrienne Levine.
Thank you, Rick, and welcome everyone to UCLA Engineering. Our department houses 2 majors, mechanical engineering, which in my opinion is the broadest major in the school, despite what some of my colleagues may say, and aerospace engineering, which is probably the most focused. So mechanical engineering addresses motion and energy. If you think about all of the engineered systems that involve either motion or energy, well, they're pretty much countless. Familiar things like automobiles, exotic nanoscale devices, the flow of blood in an artificial heart, power plants, emerging alternative energy sources, and much more. This is the broad domain of a mechanical engineer. And just about any industry that employs engineers will employ mechanical engineers. Then we have aerospace engineering. It addresses aircraft and spacecraft, very focused. And these are things that really capture the imagination, flight and space exploration. Students can get very passionate about aerospace engineering, like our Rocket Club students who designed, built, and launched this rocket that you see in the slide behind me, or like Megan MacArthur, whom you'll hear from in just a moment. So whether you're interested in aerospace engineering or mechanical engineering, the strong fundamental education that you'll receive at UCLA will prepare you not only to improve upon familiar engineered systems like cars and planes, but also to continue to learn throughout your lifetime, to attend graduate school and contribute to knowledge as our faculty and graduate students do, and to conceive of and create innovative solutions to the world's pressing problems. Our students are fantastic. They're bright, hardworking, motivated, creative, collaborative, probably sounds a lot like you. And they come to UCLA with a little knowledge and a great desire to learn to analyze and create devices or processes that benefit humanity or just make our lives a little more interesting. And they learn from their professors in the classroom, but also from the other bright students around them. And some seize the opportunity to do research in faculty labs. Many do summer internships in industry. And also there are a lot of students who are involved in the projects from our student societies. We have chapters of the American Society of Mechanical Engineers, the American Institute of Aeronautics and Astronautics, the Society of Automotive Engineers, and also UCLA Robotics. In fact, you'll see some of those projects if you come to our departmental open house later today. You'll meet those students and see just how creative, dynamic, and articulate they are. So please come to UCLA, join them, and be part of all that excitement. Welcome.